So this is 3.8, number 27. So they are asking to verify that this point lies on this curve. Now, I believe there's a squared there. Let me double check. Got cut off. Yes, indeed. So how do you verify that a point is on the curve? Well, you just plug it in. You plug this in for x, and you plug that in for y. There's a cat walking in my backyard, just letting you know. So let's do that. We're going to get sine of pi plus 5 times pi squared over 5 equals pi squared. Well, this is nice. Those cancel. Everyone knows the sine of pi is 0. So we end up with pi squared equals pi squared. When is this true? Always. Therefore, this point is a solution. And they give us that point right there. So that point is that. So now they want the equation of that red line. That's easy. It's y minus that equals, and it's x minus that. So I put pi squared over 5. All I need is a slope of this red line. And what tells us the slope? The derivative. So let's find the derivative. We have sine of y plus 5x equals y squared. The derivative, or the slope of the line, is going to be dy dx. So y is the function, x is the variable. We have a function here and a function here. Treat that just like it were f of x in the chain rule section. All right, that's supposed to be red. That doesn't count as a mistake. Just letting you know. If I catch a mistake, it doesn't count as a mistake. Let's go. Sine of box, sine of a function, a function, a function. The derivative sine of a function is the cosine of the function times the derivative of the function. Derivative of that is just 5. I can do that. And what's the derivative of box squared? It's 2 times box times derivative of box. Let me move this out of the way. Let me just get rid of that. Now, anything with a dy dx we want on the same side. So we're going to end up with this. I copy that. I'm going to subtract this from both sides. So I end up with a minus 2y dy dx. And I'm going to subtract, I'm going to subtract this from both sides. So that's going to become a negative 5 on the right side. I have a common factor of dy dx's. I'm going to take those out. And I have cos y minus 2y equals negative 5. And then the last step, I divide both sides by that blob. And I get dy dx is negative 5 over this. All right, that's my derivative. But here's the deal. I want the slope specifically at that point. So I got to plug that point in, pi over 2, 5, pi. So what I really want is dy dx at the point where xy equals, I got to look again, pi squared over 5 pi. Let me double check that. Pi squared over 5 pi, pi squared over 5 pi. So I'm going to plug that in here. So what's nice is all they want is pi. They don't want x. There's no x there. So it makes life easier. So this is going to be negative 5 over cosine of pi minus 2 times pi. But everyone knows cosine of pi is negative 1. And since everything is negative, it'd be wise to multiply by 1. That will get me 5 over 1 plus 2 pi. That is my slope. I'm going to place that for my slope in my equation. 5 over 1 plus 2 pi. 5 over 1 plus 2 pi. Bam!